Hey there class, Mr. Prosky here. Hope you're having a good day so far. We're continuing with 3.6 in geometry. This lesson is prove theorems about perpendicular lines. Our essential question is, what are the theorems and postulates regarding perpendicular lines? So this is kind of a review from 3.4. It says, are the following lines parallel, perpendicular, or neither? So go ahead and figure out how you would do that. I'm not going to give any hints, and you can pause the video and give it a try. All right, so the way we can tell that lines are parallel is they have the same slope. Perpendicular have opposite reciprocal slope. Okay, and then neither is just anything that's not one of those two things. Okay, so let's figure out the slopes for these. We have m equals, remember, label our points, x1, y1, x2, y2. So we're going to do y2 minus y1, so we have 0, minus -5 or plus 5 over x2 minus x1, which is 7 plus 2. So that's going to be 5 over 9. Okay. Slope of the second line should be, we label our points again, x1, y1, x2, y2. Until you get it like pretty fluid and pretty fluent with this, you want to avoid, I would label your points every time to not make any mistakes, okay? And remember the slope formula, we're forgetting what that is y2 minus y1 over x2 minus x1. So y2 minus y1 is going to be -2 minus 8 over, we have x2 minus x1, which is -4 minus 5. No, sorry, minus 1, my bad. So that's going to be what? -10 over -5. And -10 divided by -5 is 2. Make sure when you're doing these that you reduce your fractions because you could have, like, for example, you could have 10 over 18, and that would, if you were to reduce that, that would be equal to 5 over 9. So it's basically the same thing, okay? So what is this? Are these, here's the slopes. Are these parallel, perpendicular, or neither? These are neither because they are not the same and they are not opposite reciprocals of each other. All right, moving on. So, some definitions. The distance from a point to a line is the length of the perpendicular segment. The what? The perpendicular segment from the point to the line. So basically, distance is always at a right angle between the two things. Okay? So for example, if you have if you have a dot and a line like this would not be the distance right here, right? Because that's like an angle. The distance is going to be at a right angle like that. This is the distance right here, okay? So be careful with that, all right? So yeah, the shortest distance between two things is a straight line. Kind of the same thing we were talking about. Okay? All right, so a couple things here. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay? So G is perpendicular to H. All right, if they make a linear pair and the angles are congruent, then they're going to be perpendicular. Okay? And down here, if two lines are perpendicular, then they intersect to form 4 right angles. Okay? Same thing down here, right angles. All right, sounds good. A couple more theorems. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. They're what? Complementary. So same thing here, complementary. All right, sounds good. Perpendicular transversal theorem. If the transversal is perpendicular to one of two parallel lines, then it is perpendicular to another. So if you have two parallel lines, it's perpendicular here, it has to be perpendicular here as well. Okay? All right, and then it's kind of like the converse, lines perpendicular to a transversal. If they're both perpendicular to the same line, then these are going to be parallel lines. Okay, they are parallel to each other. All right, so yeah, just a few proofs there. I'm not going to get into that too much. We're going to cross out this proof. It's a really bad proof. We're not going to do it. Let's talk about example 2 now. Example 2 says use the angle pair relationship to solve for x. Okay. So we have these two angles here. What do we know about these two angles? Well, we know this right here is 90 degrees. So that means what over here is, this is also going to be 90 degrees. So what are we going to do? Are we going to set these equal or are we going to add them up to something? We're going to add them up to 90, right? So we're going to do 4x plus 1 plus 37 equals 90, okay? All right. So they have to equal 90 because the other side equals 90. Go ahead and pause the video, see if you can solve this. All right, combining like terms. 1 plus 37 is going to be 38. Solving for x, subtract 38. We get 4x equals, what's that, 52? Divided by 4. And x equals what? 13. 13 degrees. All right, why don't you guys try these checkpoints here. See if you can do 1, 2, and 3. And be aware for number 3, you might get a weird answer, so just be aware of that, and that's okay. Numbers 2 and 3 are kind of a review of the other things we've talked about in this chapter with different parallel lines. But see if you can figure these out. Go ahead. All right, so checkpoint 1. We have 2x plus 6 and 5x, and these angles add up to 90 degrees. So we're going to literally add them up. So we got 5x plus 2x plus 6 equals 90 degrees. All right. Combine like terms. 5x and 2x is 7x. Solve for x by subtracting 6. 7x equals what? 84. Divide by 7. And x is going to be equal to 12 degrees. Okay, number 2. We have 9x minus 4 and 130. What kind of angles are these? Looks like they're between the lines and on the same side of the transversal. These are consecutive interior angles. Are these congruent or supplementary? They are supplementary, so we need to add them up to 180, okay? So remember, only linear pairs and consecutive interior angles are add to 180, okay? The rest of them are going to be equal to each other, okay? So 9x minus 4 plus 130 equals 180. All right. Combine like terms. Negative 4 and 130. We have 9x plus 126 equals 180. All right. What do we do now? Subtract 126. 9x equals 180 minus 126 is 54. Divide by 9. And x is going to be equal to 6 degrees. All right, last example here for these checkpoints. We have 123 and x plus 129. What kind of angles are those? Those are alternate interior angles. Are those congruent or supplementary? They are congruent. So we're going to set them equal. So we got x plus 129 equals 123. Solve for x now by subtracting 129. And this is kind of what I was talking about. We're going to get a weird answer. We're going to get x equals negative 6 for this one. Negative 6 degrees, which is kind of a weird thing, but it is what we got. Okay, we are actually going to cross off example 3, and we're going to cross off checkpoint 4. So that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.